Hi friends, today we'll discuss about total internal reflection. It's one of the important topic from the chapter Optics of grade 12 CBSE syllabus. We can see what is the phenomenon first of all. Total internal reflection happens in our daily life in 2-3 cases. Like, in hot summer days, we used to feel some watery surface on a far distance. Like when you drive on the car on a flat road, at a far distance we could see some water surface. But when you reach there, it won't be there. The phenomenon is called mirage. It is an application of total internal reflection, which happens in the air, atmosphere. Another one is there for communication field, we use optical fiber cables. In short, we call as OFC. Is also working on the principle of the total internal reflection. And one other thing is, reflectors. On vehicles, we use the reflectors. On the road, we use reflectors. They all use right-angled prisms. This material also works on the principle of total internal reflection. We can see what is a phenomenon, first of all. It's a phenomenon in which during refraction, if light ray passes from denser to rarer medium, it completely reflects back instead of refraction to the denser medium itself. When the angle of incidence is greater than the critical angle of the medium. We can analyze these terms. I use the word denser medium. Denser medium. It is one in which refractive index is comparatively greater than the next medium. So the other medium will call as rarer medium. So light ray should pass from denser to rarer medium. This phenomena can take place. And one more condition is there. The angle of incidence, we call as I, should be greater than the critical angle of the denser medium. Then total internal reflection will take place. What is critical angle? During refraction, for example, is a surface separation between water and air. When light ray passes from water, this is an incident ray, to the air, if you draw a normal at the point of incidence, then it refract away from the normal. This is angle of incidence and this is angle of refraction. And if you increase the angle of incidence further, you can see it will more bend away from the normal. And at a particular angle, you can see that from the water, air, the same concepts. At a particular angle, this incident ray will refract along the surface of separation. That is, the angle become 90 degree. Then this angle is called critical angle of the medium. So we can define this critical angle as the angle of incidence in the denser medium in which the angle of refraction becomes 90 degree. So I hope you got the concept. Now, if further again you increase the angle of incidence, like you come to this side, then it will become like this way. Instead of refraction, completely the ray will reflect back. This phenomenon is called total internal reflection. So, critical angle and denser to rarer medium. These 2 points you should notice. Now, we can see Snell's laws of refraction. Sin I over sin R is equal to N2 by N1, where I is the angle of incidence in the first medium, R is the angle of refraction in the second medium, N2 is the refractive index of the second medium, and N1 the refractive index of the first medium. At critical angle, suppose I is equal to IC, then you can see that sin IC over sin 90 degree, because angle of refraction become 90 degree here, is equal to N2 by N1. All of you know sin 90 is 1, so we could say that sin IC is equal to N2 by N1. And if the rarer medium is air, then N2 will be 1. So we could say sin IC is equal to 1 by N1. This is a relation between refractive index of two mediums and the critical angle. For water it is around 49 degree, and for glass it is 42 degree, the critical angle. Now, in the beginning I mentioned to you that there are three phenomena which happens about the total internal reflection. One is optical fiber cables. We can see what happens in optical fiber cables. In short, we call as OFC, optical fiber cables. These cables are mainly or basically made up of glass materials. There are two parts of this material. One is a core material. It will be a rarer, denser medium, and it is covered with a rarer material like other less than refractive index of glass. So this is the core and this is called cladding. When light ray incidents in the core, this material is designed in such a way that the angle of incidence will be greater than the critical angle of this core, so that instead of refracting, it will reflect back to the same core and it will be continuing throughout the end. So you could see that the light ray will comes out on the other end only. As much you curl around the core or you bend it, doesn't matter, the light ray will enter on the other side only. There is no loss of energy happens. Normally in our telephone communication channels, we use copper wire to pass the sound waves in the form of electricity. There are a lot of heat used to loss in the form of, so energy loss is there. In this case, there is no energy loss. So transmission loss is very less in this concept. It works, make use of optical fiber cable. And then I mentioned about the right angled prisms. A prism with 90 degree, one of the angles 90 degree, will call as right angled prism. If a light ray incidence like this way, for example, it is the normal incidence, so it will pass through straight way, and at this point, if you draw in normal, you can see this angle become 45 degree. So it is more than the critical angle of the glass. It will comes back to the same medium and it will pass through this one. So instead of a refraction, this light ray is reflected at 90 degree. Similar way, if you use this prism as a reflectors also, for that purpose we'll draw this like this way. We keep it. This is 90 degree. If a light ray passes like this, it will reflect and come back. So right angle prism also works on the principle of total internal reflection. So friends, we have discussed about total internal reflection. The phenomena is the complete reflection of light rays into the same denser medium when the angle of incidence is greater than the critical angle. Two criteria is needed there. The light ray should pass from denser to rarer medium and the angle of incidence should be greater than the critical angle. Three major applications we mentioned, and I explained about optical fiber cables and the right angled prisms. That's all. Thank you for watching.
Bright Education Center, Medical and Engineering Entrance Coaching Center, Hilal area, Doha, Qatar. For further enquiries, contact 306000679.